Welcome back. In the previous class, what we found that how to define positive definite matrices. Okay, and what we found that one can perform at least 5 equal tests to confirm that some matrix or given matrix is positive definite or not. Okay, now what I am going to do, I am going to use that positive definite matrices, and I have already told you that associated with positive definite matrices we have always some kind of energy like function. Okay, and people are telling energy function also directly. So with help of that function, now what I am going to do, I am going to apply the Lyapunov direct method to show that some system is stable or not. Okay, so I can talk about stability of linear system as well as nonlinear system, but believe on me that stability of nonlinear system or constructing Lyapunov function for nonlinear system is not a trivial task. Okay, most of time that is very difficult. So some intuition is required, some kind of idea of solution is required, some kind of physical intuition is required. Then only one can construct Lyapunov function for some kind of nonlinear system. But at least we are happy that for linear system we have some kind of systematic way to create Lyapunov function. Now one question is very obvious. I have also told you in previous class that we have well-known result for linear system, both linear time varying system and linear time invariant system. So one can easily ask the question that okay, if I have linear time invariant system, I can calculate the eigenvalue and after that I will check the stability. Why I will go to construction of Lyapunov function? Okay, so answer, one of the possible answer in this direction is that we are going to develop some kind of common language where I can treat the linear system as well as non-linear system. So common language I am going to develop, and Lyapunov language or Lyapunov direct method is help in doing that. Okay, another more important thing, nowadays you might have seen that system is very complicated. So even if I have some kind of linear system, that is cascaded linear system, or some kind of system where cascading of linear and non-linear system is there, and it is possible to show that energy function is a scalar. So I will define some scalar function for some subsystem, similarly another scalar function for another subsystem, and since energy is additive we can add it and try to construct the final Lyapunov function. Okay, so construction of Lyapunov function for linear system will give another insight that suppose if I have nonlinear system and if we are able to extract some part that is same as linear system, then I know that at least for that part I have this kind of Lyapunov definite Lyapunov function construction. Okay, and after that we try to add something more and try to modify that Lyapunov function, and then finally we are able to construct the Lyapunov function for nonlinear system. So due to that reason we are trying to develop Lyapunov function construction for linear time varying system or linear time invariant system. So we have just two motivation. First motivation, we are going to use common language. In that language I can cover linear system as well as nonlinear system. And second important point, that what we have to do, if I have nonlinear system, then I am trying to extract some part of linear system from the nonlinear system, and same construction I am going to do there and try to see that what kind of extra limitation or restriction comes into picture. So let us start the today's lecture. So I have considered, first I am going to consider the linear time invariant system. So my system is linear time LTI system, and x dot equal to ax. Okay, and you have already seen that for this system I have unique equilibrium point provided determinant of a not equal to 0. Okay, so and if determinant equal to 0, then or you can see that if I have two isolated equilibrium point in case of linear system, so by linearity principle I can tell that if you join some line between here to here, then every point is also the equilibrium point. This is just obvious from the linearity. Due to that reason, I cannot claim that for non-linear linear system I have isolated equilibrium point. So that is another proof just by linearity. Okay, so what kind of assumption I have? I am assuming that determinant a not equal to 0. In this way, x equal to 0 is the unique equilibrium point. Okay, now I have to talk the stability of this unique equilibrium point. Okay, so here whenever I am going to talk about the stability of the equilibrium point or stability of the system, for linear system both are the same. Okay, because property of stability is fully determined by this particular matrix. Okay, so and we have already seen that if eigenvalue or real part of eigenvalue of A, if that is strictly negative, then I can tell that this system is stable. Okay, so now I am going to construct Lyapunov function obviously for the stable system only. Okay, because I have already told you that whenever I have some kind of way to construct energy function, so Lyapunov function is just tell us the sufficient condition. Sufficient condition means if Lyapunov function will exist, then I can tell that okay, x equal to 0 is stable, asymptotically stable, exponentially stable. But if that doesn't exist, then I cannot comment. Okay, so now what I am going to do, I am going to construct Lyapunov function for a stable linear system. And what is meaning of a stable linear system? That I am assuming that real part of eigenvalue of matrix A, that is less than equal to 0. Okay, so that kind of assumption I have, and in equivalent way we are telling that this matrix A is Hurwitz. Okay, now what I am going to do, I am going to select one kind of matrix P from the previous lecture, and this P is symmetric. We have already seen that why I am going to take symmetric, even if you will take general matrix, but contribution of asymmetric part during construction of energy, that is 0, and due to that reason we limit ourselves on the symmetric matrices and positive definite matrix, because I know that I have to construct Lyapunov function like this. Vx should be greater than 0 for all x not equal to 0, and Vx equal to 0, that should be 0. So this kind of condition I require. Okay, and due to that reason what I am going to do, that I am going to take this matrix, positive definite matrix, and in previous class we have already seen that if I construct this kind of matrix, then I have similar kind of property. Up to here anyone has confusion, then please let me know. Baby Diana, up to here any confusion?
No, sir.
And one more important thing, that whenever you are going to construct the Lyapunov function, please be careful, all state information should be there. If you miss some state information, it means that you do not care the energy associated with that particular element. Okay, so once Lyapunov function is constructed, after that we have to see the derivative of Lyapunov function along the system trajectory in order to talk about the stability, asymptotic stability or exponential stability, whatever. Okay, so in first part of this lecture I will talk about two stability, that this is stability, and if a strict condition is there, then we are going to talk about the asymptotic stability. Okay, now Sunidhi, could you please tell me that if x equal to 0 is the equilibrium point, and if second condition is satisfied, v dot less than equal to 0. Okay, so that is that is local asymptotic stable or global asymptotic stable in case of linear system?
It's a global asymptotic stable.
Yeah, global. Why global? Because we know that linear system, whatever, in case of linear system, if I know the behavior of linear system in this region, I can able to extend same kind of behavior due to linearity, same kind of behavior throughout the space. Okay, so if something is stable or asymptotic stable in this small region, I can tell that equivalently same kind of property hold even if you can take any larger initial condition. Okay, and another way to check that whatever Lyapunov function you are going to construct, that should be radially unbounded. Okay, and you can see here that as x tending towards infinity, v is also tending towards infinity. Due to that reason, this is radially unbounded. Due to that reason, I am telling that whenever we are talking about asymptotic stability of linear system, a linear system means I am going to just talk about x dot equal to ax. There is no perturbation, there is no disturbance. Then in that particular situation, I am going to talk about the global asymptotic stability. Okay. Now what I am going to do, I am going to take the derivative along the system trajectory. So v dot, I have x transpose p, so I have x transpose px. So v dot is x dot transpose. So this first term, and again p is constant, due to that reason derivative with respect to p is 0, because what I am going to assume that p is positive symmetric definite matrix and each entry is the real. Okay, and I am not, for time moment, I am not allowing that some kind of input which is depending on a state or time. Okay, so due to that reason I have just two terms, and now you can substitute x dot, and you know that x dot is ax, so I have substituted here, and similarly I have substituted here. And after that, what I have to do, we know that if I have AB transpose, then that is B transpose A transpose, and due to that reason I have X transpose and A transpose, and after that P and PA into X. Okay, now what I have to make sure that V dot less than equal to 0. Okay, so either this condition, then I can talk about stability. If this condition, then that is very fine for me, that I can able to talk about the global asymptotic stability. Okay, so due to that reason, what now I am going to do, I am assuming that this matrix, because here A is coming from system, P I can construct. Okay, so I am going to assume that since P I can choose, so I am assuming A transpose P plus P equal to minus Q, and again I am going to select Q as a positive symmetric definite matrix. Okay, so because now you can see that this equation is matrix differential equation, matrix equation, not matrix differential equation, some kind of matrix equation we have. So we are telling that okay, A transpose P and PA, if that is minus Q, then negative sign I will take it out, then I have this kind of situation. I have something like X transpose Q into X, and if Q is positive symmetric definite, then Nidhi, could you please comment X transpose QX? What I can tell about X transpose QX? First you can leave the negative sign.
Sir, in terms of?
In terms of energy, in previous class we have seen that if Q is, if I will select Q symmetric positive definite, okay, then X transpose, what is condition on X transpose QX? If Q is symmetric positive definite,
Sir, it should be greater than 0.
yeah, greater than 0. Okay, and negative sign is there, so then what happens? This is less
The V
than
dot
0.
will be less than 0.
Yeah, less than 0. Okay, so due to that reason we have chosen this particular condition, because I want V dot less than 0. Okay, in the weak case you can select Q as a not positive definite, positive semi definite also, that is allowed. Why? if I will select positive semi-definite, then I can talk, at least I can talk about the stability. Okay, so Q, either I can select positive semi-definite or positive definite. So if I will select positive definite, then I can give guarantee that x equal to 0 is globally asymptotically stable. Okay, so meaning is that for linear system, if I start anywhere in the space, state space, then I am going to converge to the equilibrium point. Okay, so now whole process of construction of Lyapunov function, because how basically I am going to construct Lyapunov function, I am going to construct Lyapunov function like this, x transpose px, and I know that I have to make sure that this equation has solution. If this equation has solution, then I can tell that I have Lyapunov function. Okay, so Lyapunov function construction is now just reduced to some kind of matrix equation. I have to solve this matrix equation, and if there exists a solution, then I can pick that P and club here, and after that I can give guarantee that this, for this linear system, linear time invariant system, I have this kind of Lyapunov function. So whole story is now boils down to solution of this equation, and this equation is very famous in the control literature or other literature also, linear control literature, even if mathematics literature also, that is very famous, and this equation is called Lyapunov equation. Okay, Q you can select positive semi-definite and positive definite. I hope that you are able to understand the motivation, because somehow I have to make sure that V dot should be strictly less than 0 in case of global asymptotic stability, and if I select Q that is symmetric, positive symmetric definite, then I can able to make sure. Okay, so I have already written this equation as a Lyapunov equation. Okay, now what I am going to do, I am going to check one of the very important thing, that suppose A is Hurwitz. Okay, I am going to construct Lyapunov function only for a stable system, because on a stable system there is no meaning of Lyapunov function, and due to that reason, in advance we are assuming that A is Hurwitz. Anyone has confusion on this point, then please let me know, because if something is not stable, then how one can talk about the asymptotic stability? Due to that reason, I have inherent assumption from our previous knowledge that we know in case of linear system, if A is Hurwitz matrix, then system is stable. Okay, so I am going to use that kind of knowledge. I am going to only construct Lyapunov function for a stable system. A stable system means I am assuming that A is Hurwitz matrix. Now I have two pair, Q and P. Now question is that how to select P and Q. Is it possible first I will select P and then we will come up to Q, or vice versa? Okay, which way is more appropriate? So we are going to see this. Okay, so for that I have taken very simple example. I have taken one second order system. Okay, second order system, here x is nothing but x1, x2. I have two state variable, and you can see here that I have A is 2 cross 2 matrix. Now here if you see the eigenvalue, you can see that both eigenvalue is strictly negative. Okay, so if both eigenvalue is strictly negative, Carol, could you please comment what is behavior of this system or equilibrium point?
Stable system.
Yeah, stable system. Okay, so whenever you are going to construct Lyapunov function, we are just concentrate ourselves on a stable system. And in another way also you can see that I can define some kind of transformation like z equal to tx, and after that I will do z dot, that is tx dot, and in place of x dot I am going to substitute this ax, and after that now I am going to select this kind of transformation, and so this kind of transformation I am going to select such that I can able to write T18 inverse like -4 0 0 -8. Then what happens, I have second order equation is reduced to first order equation. Several times in other courses I have talked about this methodology, that whenever you have higher dimensional system, and if you have linear system, then what you can do, you can check the eigenvalue, and if all eigenvalue are strictly negative or positive, that doesn't matter, different, then I can equivalently convert that n dimensional system to n number of independent or decoupled linear system in different coordinate frame. Okay, so similar kind of things I have done. Since lambda 1 is minus 4, now since if you see z1, so z1 dot equal to 4 z1, and now since we are in only one dimensional space, so I have drawn one axis, and after that I will check the sign of z1 and z1 dot. So at this moment you can see that if zi I have taken, means 1 and 2 both are similar kind of behavior for z1 and z2. If that is greater than 0, then z dot is less than 0, and some quantity is greater than 0 and their rate of change is less than 0, and that is only able to move in one dimension, and due to that reason I have only one possible choice, I can move towards the equilibrium point. I hope that I have already talked about this, so you all are already well aware about this point. If anyone has confusion, then please let me know. Anyone has confusion? Rajesh, is it clear to you?
Yes,
Rajesh,
sir.
do you have confusion on this point?
Yes, sir.
What I am telling, that quantity is greater than 0 and their rate of change is less than 0. So from Newton's law, I can tell that that is decreased towards the equilibrium point. Here quantity is less than 0 but rate of change is greater than 0. Again, that is converging towards the 0. Okay, so that is the one way. Now what I am going to do, at least I understood in some sense that this system has a stable behavior. Okay, so using Lyapunov theory, now I am going to extend something more. I am going to talk about the global asymptotic stability. Is it possible to talk about global asymptotic stability or not for the same system? So what I am going to do now, we have already seen that in order to talk about global asymptotic stability, I have to construct some kind of Lyapunov function for linear system like this, and after that finally if I will check this kind of things, v dot less than 0, then at that time I have to just solve this equation, pa equal to minus q. Okay, so now there is no need to do this step. Directly I can jump to this particular equation, a transpose p plus pa equal to minus q, and what I am going to do in first way, that I am going to fix p. So I have fixed p equal to identity matrix, identity 2 cross 2 matrix. So I am going to select this. Okay, so Sunidhi, could you please comment that why this is positive definite?
Sir, its eigenvalues are positive, or we can say
eigenvalue are
determinant is
positive, or you can see that here determinant is 1, that is positive, and after that you can calculate determinant of whole matrix, that is again positive. Okay, so from that test also I can able to confirm that P is positive symmetric, and obviously P equal to P transpose. So this matrix will satisfy the criteria of positive symmetric definiteness, and whatever energy associated with this matrix, that is already greater than 0 by the similar analogy or energy test I can tell. Okay, now what I am going to do, I am going to substitute, since I know the system matrix A and P I have chosen, that is very simple, that as a identity matrix. Okay, and after that what I am going to do, I am going to substitute this. Now you can see that whatever minus q I have received, that is 0, minus 4, 4 and minus 24. Okay, so could you please comment on this, that q is positive definite or not? Just you can cancel the sign. So is it positive definite? How to check? Simple, minus sign you can put everywhere. So 0, minus 0 and 0 is exactly the same, 4, 4 and 24. You can see that this is 0. Okay, so obviously this is not positive definite. So that is positive. Then we will tell, okay, q is positive at least positive semi-definite. So what I am going to do now, I am going to check this determinant of this whole quantity. So here 24 is there, so this is 0, and after that this is positive, so 16 minus 16 is there. So this matrix is no longer now positive semi-definite. Okay, so what people are telling, that if you start from the P, it might possible there exists some kind of situation where Q become indeterminate. Okay, I cannot comment that is positive definiteness or negative definiteness of Q. Okay, even if I cannot comment about positive semi-definite or negative semi-definite of this. Okay, and due to that reason, conclusion is that whenever you are solving the Lyapunov function, so it is bad choice that if I am going to start from the P. Okay, so what is another possibility? Could you please guess? Baby Diana, could you please guess what is another possibility then? Baby Diana, are you here?
Yes, sir. Yes, sir.
So could you please guess what is another possibility we have? So what we have seen, A is already given, always given to us. So what we found, that if I select P, it might possible there exists some kind of case where I cannot talk that Q is positive definite or positive semi-definite. So what do you think? What is way out?
Sir, we can select Q. After that, we can.
Yeah. So another way, now we are going to look that if I select Q, then is it possible to give guarantee that P is positive symmetric definite or not? Okay, so Q I will select positive symmetric definite, and after that now I am going to look towards the P. Okay, and we are going to see that it is possible to show that always that kind of situation exists. If A is Hurwitz, Q is positive symmetric definite, then I can able to give guarantee that P is also positive symmetric definite. Okay, so why we are going to avoid this way selection of P? Because in mathematics, if something is wrong at one point, then it is possible to show that might be wrong for several points. So by proof by counter example, if you have to disprove something, just you can create one example. Okay, then what happens, whole theory is going to collapse. Okay, so what I am telling, that I have theory like I have to solve this. So I have created one counter example where I know that A is Hurwitz, P I have selected positive definiteness, and Q is sign indeterminate. So due to that reason, now theory is collapsed that if you are going to select P, then Q is, there exists a Q such that Q is positive symmetric definite. Due to that reason, I am going to avoid this way. So similar kind of conclusion I have written here, that therefore no conclusion can be drawn from the Lyapunov function on whether the system is stable or not, because Q matrix is signed indefinite. So if Q matrix is signed indefinite, then how come I can able to talk the positive definite means stability of the system or equilibrium point? Here please be careful. What I am going to talk, I am going to talk about stability of system or stability of equilibrium point. Both are same for linear case, but for non-linear case we have to become very specific. We have to talk stability about the equilibrium point. I cannot talk stability of whole system, because it might possible in nonlinear system I have several isolated equilibrium point. Some equilibrium point is stable, some one is not. Simple example of pendulum you have already seen, that if we are about the below equilibrium point, then that is stable, but upper equilibrium point, that is unstable. Okay, so whenever we are talking about stability of linear system, either you can tell that equilibrium point is stable or linear system is stable, both are the same. Okay, so now what I am going to do, I am going to select another approach. Another approach is that choose a positive definite matrix Q and then solve this equation to get the P, and after that you can check that P is positive definite. Okay, so that is the another way. And if P is positive definite, then X transpose P is a Lyapunov function for the linear system, and we have already seen that there is global asymptotic stability. I can give guarantee that system is globally asymptotically stable. So same kind of things now I am going to capture using the next theorem. So what next theorem is suggesting that a matrix A is Hurwitz, that real part of the eigenvalue that is less than 0 for all eigenvalue of A. And you can see here I am writing if and only if given positive definite symmetric matrix Q there exists a symmetric definite matrix P. Okay, so this result is very strong. What this result is telling, that this matrix A is Hurwitz only if you select some Q and if there exists a positive symmetric definite matrix P, then I can give guarantee that A is Hurwitz. Okay. Another way, if A is Hurwitz and if I select some kind of positive definite matrix Q, then I can give guarantee that P is also positive symmetric definite. And due to that reason, this condition is there, if and only if. Okay. So if you assume A is Hurwitz, then you can tell that given a matrix Q, positive symmetric definite matrix Q, there exists a positive symmetric definite matrix P. And vice versa, if you are going to take one kind of positive symmetric definite matrix Q and going to take one positive symmetric definite matrix P, then there exists a Hurwitz matrix. Okay. Anyone has confusion? What I am going to say here? I am telling that is if and only if. If and only if means either you can fix A as a Hurwitz, means if you have a stable system, then if you select Q, then there always exists a P. And if there always exists a P, I can construct the Lyapunov function. Another way, now there is no need to check that A is Hurwitz or not. If I have some given linear system and I have to show that system is stable, then what I will select two positive symmetric definite matrix and then I will check the A is Hurwitz or not. If that is, then I can tell that okay, that system is stable. Okay. And moreover, you can see that A is Hurwitz, then P is unique. Okay. If A is not Hurwitz, then I cannot talk about uniqueness of P. But if you fix A, then it is possible to show that solution of this Lyapunov equation, that if A is Hurwitz and if you select any Q, then whatever P I am going to get, that is unique. Okay, I have just unique choice. Anyone has confusion? Have you understood this theorem, baby Dana?
Yes, sir.
Okay, so because most of time this kind of equation is useful whenever either you can work on robust control, linear control, any control theory. And most of time what common mistake a student is doing, they just try to fix the P and after that they are going to find the Q. Okay, but that is the wrong way. Okay, sometime if I have thousands of order of some linear system, at that time I do not know that A is Hurwitz or not. So for that, what you can do, you can select two positive symmetric definite matrix, club here and try to check the A. Okay, and if your system is stable, then A is Hurwitz. Okay, now let us try to see the proof. Okay, so now since this theorem will work in both directions, if and only if condition is there, so I have necessary and I have some kind of sufficiency as well as necessity. So sufficiency is follow from the Lyapunov theorem, because if you select this and if you select this and after that I have come up with the Lyapunov function A transpose P plus PA equal to minus Q, and what we are telling that if A is Hurwitz matrix and Q is somehow positive symmetric definite matrix, then obviously x equal to 0 is the asymptotically stable. Now I have to prove the necessary condition of this particular theorem. So what we are going to do, we first show that given any symmetric positive definite matrix Q, you can see that here any, so for all positive symmetric definite matrix Q, there exists a positive symmetric definite matrix P. Okay, so now I have to select all possible, or I have to talk about all possible choices of the positive symmetric definite matrix Q. Okay, so what I am going to do, I am going to construct some kind of positive symmetric definite matrix Q, and I have to also somehow involve that A is Hurwitz. So that two condition I have to club. Okay, so what I am going to do, I am going to tell that okay, if I have some matrix Q and since A is Hurwitz, at that time I am going to construct matrix P as this. Okay, so you can see that this case is very wide case, not simple case. And what is main motivation? Main motivation is that if A is Hurwitz, then exponential function that is going to decrease. Okay, so now you can see here that exponential function and same exponential function is multiplied here and Q is here. So somehow I have a structure like whatever structure we are talking, that you can take one vector and take transpose of that vector, that quantity Q is positive symmetric definite, and after that I have some quantity, same kind, some same column vector I am going to multiply here, and whatever quantity, if Q is positive symmetric definite, then what one can comment about X transpose QX? Anyone? Baby Dana, what I can comment? Suppose Q is positive symmetric definite. Okay, because I am assuming during theorem, I am assuming that A matrix A is Hurwitz and Q is positive symmetric definite, and after that I am going to check the condition on P. So if I write like this, then what I can comment?
Sir, A transpose P plus PS is less than 0.
No, X transpose QX from positive definiteness of matrix. Is it possible to comment X transpose QX greater than 0?
Yes, sir.
From energy test, if Q is positive symmetric definite. I am
Yes,
assuming
sir.
that PSD, this is positive symmetric definite. Now you can see that what I can comment about integral of this. If some positive quantity is there, then what is integral of that? If I am now in place of this column vector, I am going to use those kind of vector which is changing with respect to time. Okay, so now is it possible to give guarantee that if column vector that has time varying component, so for all time this is greater than 0, is it possible to give guarantee or not?
Yes, sir.
It is possible, because already this kind of construction is telling that is greater than 0. Okay, so now in this way, in place of X, now I can involve anything that is in form of the some kind of quantity which is changing with respect to time. And we already well aware that if I have some kind of system like this x dot equal to a power ax, then solution is coming of this form e power at something x0 like this. So this is the motivation to select this part A transpose P. Transpose is required to X transpose X, that kind of construction. Due to that reason I have written here transpose. And one important quantity is that you can see that P is not blowing up, because why? This A is always Hurwitz. Due to that reason this whole matrix, this is nothing but some kind of matrix. Why I am telling matrix? You can see that P is Rn cross n matrix. Okay, so this is matrix, and after that Q is also matrix, but their product, I am going to talk about the product of this three quantity. So three quantity, whenever I am going to talk about the product of this quantity A transpose P and Q, and after that exp A transpose E. So what do you think? What is product of this quantity? A scalar or vector?
Scalar, sir.
A scalar? if that is a scalar, then how I can construct X transpose Px? If that is a scalar, and here you can see that this is R n cross 1, R n cross 1, so transpose is 1 cross n, so I cannot construct, okay, and due to that reason, actually I am going to define in such a way such that this remains vector only, okay, P remains the vector, okay. Now I will check other thing that what is sign of P or this kind of quantity, but just for motivation you can take like this, okay, and after that now what I am going to do, I am going to first check P equal to P transpose or not, and if you will do this kind of transpose, it is possible to show that P equal to P transpose. Baby Diana, this is n cross n matrix. I will tell you once derivation become over, okay. Now what I am telling that one can easily show that integral exists if and only if A is strictly stable. If A is not strictly means stable, then this matrix P each entry become infinity, okay. So P is symmetric, that is obvious. Why? You can just take the transpose of PT. It is possible to show that P equal to PT, okay, because Q is positive symmetric definite matrix and this exponential AT, exponential function of AT. So one of the easier way, suppose you have some matrix A that is R n cross n matrix, okay, baby Dana. Now
Yes, sir.
could you please tell me that what is e power A, that is a scalar or vector,
A vector.
and what is dimension?
N cross n.
N cross n, okay. Now in place of A, even if I will multiply with some scalar, then dimension is going to change or not going to change?
Remains same, sir.
It remains same, and due to that reason this is n cross n matrix. Any do you have any confusion now? And Q is also n cross n matrix and this is n cross n matrix. So what is dimension of P?
N cross n.
Due to that reason P is n cross n matrix, that is not a scalar matrix, okay. Now P is symmetric, and after that I have to prove something. I have to positive definiteness, I have to show that P is positive definite, okay. So how to show that? If P is positive symmetric definite, then I can tell that X transpose Px equal to 0 when X not equal to 0, if that is not positive symmetric definite. If that is positive symmetric definite, then I can give guarantee that this is greater than 0, okay. So proof by contradiction, what I am going to, because this is very simple to show that I will take X transpose Px equal to 0 and I am going to construct some kind of non-zero value of X. If that is not possible, then I can tell that X transpose Px is positive definite, okay. This is called proof by contradiction. So actually in mathematics I have just two situations, either quantity is false and true, and due to that reason what you can do, you can start from false. If that condition is not satisfied, then you can tell that that is true. Have you understood this or not? Sunidhi, how proof by contradiction work? Have you understood this point?
Yes, yes, sir.
I have just two situations, either quantity is true or false, okay. So I will start with false and after that I will tell that, okay, some condition is violated when I will start with false. So whatever quantity I have taken, that is true only, okay. So what I am going to, without delay, now what I am going to do, I am supposing that it is not so, that P is not, it means that I have selected positive definite, A is Hurwitz, I have constructed P in terms of Q and A, and after that I am going to tell that for non-zero value of X equal to 0, this is 0. If that is the case, then definitely I can tell that this is not positive definite by the definition of positive definite matrix. So what I am going to do now I am going to multiply this P by X transpose Px. This is called energy test. In the previous class we have seen. Now you can see that this I have selected n cross 1. So transpose of this is 1 cross n. Okay. So after multiplying these two quantity, now baby Diana, could you please tell me that this is a scalar quantity or vector quantity?
Scalar one, sir.
Yeah, a scalar one, because up to here we have seen that this is n cross n and this is 1 cross n and this is n cross 1, and due to that reason this is a scalar. Okay, so now is it possible to comment something more? Silpi is here. Silpi, are you here? Okay, so now you can see here that I can club this quantity q and after that same kind of quantity I have. So if I am telling that as a 0, then you can see I have some kind of situation. That situation is that positive definite kind of situation, X transpose Px equal to 0, and if P is positive symmetric definite, then only situation is this quantity is 0 provided X equal to 0. Anyone has confusion on this? And due to that reason you can see that whenever this equal to 0, I have only one conclusion. What is that conclusion? This quantity is 0. Okay, so that is definition from positive definiteness of matrix, because whatever in matrix that is reflected inside the integral, again that is created the energy, and where Q is positive symmetric definite matrix, so whatever vector that is associated with that should be 0. And if that equal to 0, so now I have two choices, either exponential function is 0 or x equal to 0, and we know that exponential function even if t tending towards 0, then that is tending towards 0, never that is exactly equal to 0. So I have only one choice, x equal to 0. Okay, so what does it mean? That if I will start with X transpose Px, then I have only one choice, that x equal to 0, only I have some quantity called X transpose that equal to 0. Okay, so I can tell that this function P, this matrix P, whatever matrix I have constructed, and if I multiply with X transpose Px, then that is only 0 at x equal to 0. And we know that P equal to P transpose, that is symmetric. So what kind of conclusion I can tell? Anyone? Have you understood my point or not? What I have done, I have constructed some P matrix, and why I have constructed P matrix in terms of Q and A, because Q and A is given to me. So I have to do some kind of relation. After that, what I have assumed that matrix P equal to 0 when x is non-zero. But by contradiction, what we found that x equal to 0 is only choice. Due to that reason, I can tell that by contradiction that P is positive definite matrix. What does it mean? That if Q is positive symmetric definite, A is Hurwitz, then there is no choice. Only one choice, that P is positive definite. Anyone has confusion on this point? Okay, if you don't have confusion, then let us come to the next part. Next part is now I have to prove that A transpose plus P equal to Q. So now what I am going to do, I am just going to substitute value of P here, because now I can know that if I fix Q and A as a Hurwitz, then I can get some kind of P matrix. So I am going to substitute that P matrix inside this, and I am going to verify that that is equal to minus Q or not. If that is not then I cannot tell that proper P and Q is appropriate to define the Lyapunov function. So if you club that P, so I have just done simple clubbing. So I have club here, and after that I have club here, and after that you can see that I can also define d by dt of this whole quantity, and after that if you do derivative of this, then I have two terms. One term when I will differentiate with respect to this, then I will get this. If I will differentiate with this, then I will get this. Q is constant matrix, and due to that reason differentiation with respect to t is equal to 0. Okay, so now I have just some kind of quantity d by dt like this, and dt is here. So now you can see that I have some kind of integral where dx kind of quantity is there. So what kind of things now I can tell? Anyone? What is integral of this? Sunidhi, could you please comment?
Sir, X.
X. So similarly, integral of this quantity is just whatever inside the bracket, and due to that reason I have written this, and this is 0 and a limit from 0 to infinity. Now if you put infinity, then what kind of value comes into picture? Carol, could you please comment?
Yes,
If
sir.
you,
So if
So what-
A is negative, then it would be converging. But
yeah, so since A is Hurwitz, okay, so I can able to express this exponential function in terms of e power lambda. So all quantity is tending towards 0, so multiplication with q is 0. So if I substitute infinity, then this equal to 0. What is the story about 0? 0, you can see that A multiplied with 0. So this is unity identity matrix, this is identity matrix. Okay, so due to that reason I have identity q and identity, and since upper limit I have written keep, so that is 0 and minus, and due to that reason minus q actually reflected here. Okay, so I can able to show that A transpose P and PA equal to minus q if I select P using some kind of exponential way, exp A transpose T q exp, and integral of that from 0 to infinity. So for all time I am checking this, because whenever you are defining some quantity, you have to check that is valid for each and every time instant. Stability is valid for all time greater than equal to 0. Now let us come to the uniqueness. I am going to tell that if A is Hurwitz, then I have also unique P. Okay, so only one choice of P if you are going to fix the Q. So what I am going to do, I am going to tell that, okay, suppose there exists 2P. So if there exists 2P, so for same Q, 2 equation is going to satisfy. That is, sorry, I have to write like this. I have to write, since I have 2P, so for same Hurwitz matrix A, I have this kind of condition, PA and equal to minus Q. So this kind of, I have selected P, and corresponding to Q, I have two different choices of P. So both should be satisfy the Lyapunov equation. Then only I can talk about the stability. Due to that reason, I have written two matrix equation, and after that what I have done, I have subtracted one from another, and Q minus Q and plus Q, after putting negative sign, you can see that I have this kind of expression. Now what I am going to do, I am going to multiply this equation, matrix equation. I have to solve it, and I have to show that P equal to P tilde. So that kind of things I have to show. So you can see that how basically one can show it. First, what you can do, you can multiply both sides by some kind of exponential function exp at pre and post multiplication. After that I have this kind of quantity, and finally what I am going to do, I am going to express some quantity in terms of derivative d by dt. Then only I can tell that this quantity, if that is equal to 0, then this quantity is constant. Like that kind of formulation I am going to do. Okay, and due to that reason I have multiplied with these two quantity. Okay, so proof is little bit involved, and some intuition is required to understand this proof. Obviously those who has created this proof is very intelligent person. So now here you can see that if d by dt of this equal to 0, then exponential of this equal to constant. And we know that when t equal to 0, at that time I have this quantity and this quantity as an entity. As t tending towards infinity, just now we have discussed that this is tending towards 0, this is tending towards 0, so whole quantity is tending towards 0. So that is quite fine for me, that this quantity is tending towards some constant quantity or 0. But what happens that if I am at the t equal to 0, at that time, since this equation is always satisfied, so I have only one choice, that choice is 0, because as t tending towards infinity, this should be 0. Okay, and we know that as t equal to 0, I have this as an entity and this as an entity, so I have p and p tilde that is tending towards 0. So I have just only one choice, and what is that choice? That p should be p tilde, like this. So in this way one can prove the uniqueness. So whenever you have to prove uniqueness in any mathematical result, then what you can do, you can first tell that okay, this is non-unique, then you have two choice, and after that you can come up to the conclusion that whatever two choice, that is exactly the same. In this way we are proving the uniqueness. Okay, so we have just limited way of proof. It is possible to show that if you understood 5 different way of proof, then you can able to prove anything. So you can see that in this lecture I have already used 4 different way at least. One, I have created one counter example, so proof by counter example, because I want to show that if I fix p, then I cannot talk about q might be positive definite or might not be. So that is proof by contradiction. After that, proof by counter example. After that, I have proved that by counter example that why p is positive definite. Okay, so I have taken that p is not positive definite, and after that I have proved. That is called proof by contradiction. And after that, uniqueness we have proved. And another direct proof. Direct proof means I have constructed Lyapunov function, and after that I am taking systematic way to show that something is going to come out. Okay, so slowly you have to also learn the methodology of the proof. Now what I am telling, the above theorem shows that any positive definite matrix Q can be used to determine the stability of linear system A. And due to that reason, now people are telling that if you are able to A transpose P plus PA equal to minus Q, so you are able to free to choose this Q. Okay, and A is Hurwitz, then there exists a P. So what do you think? What is simplest choice of Q? Baby Diana, could you please comment? What is simplest choice? Identity. And due to that reason, whenever you have this kind of problem, you can fix identity Q. A you are knowing, so easily you are able to construct Lyapunov function for any linear system, at least linear time invariant system. Now I am talking. After that I will extend it for linear time varying system. Okay, also now you can see that I am going to take same system. Okay, I am going to select the identity matrix Q equal to I, and after that I do not know what kind of matrix P comes out. What I am going to do, I am going to club this matrix in this expression PA equal to minus Q. Since this is second order system, due to that reason this matrix is 2 cross 2 matrix. Okay, now what I am going to do, I am going to solve it. So if you solve it, you can see that after solving this matrix equation, what kind of result I am going to get, please verify by yourself. You can see that this kind of matrix comes into picture. Okay, so Sunidhi, could you please comment this is positive definite or not?
Yes, sir. Yes,
This
sir.
is positive definite. You can see that
Yes,
5 is
sir.
positive, and after that determinant of this, that is also positive. Okay, so in this way what I can do, I can able to prove that how to construct the Lyapunov function, at least for the linear time invariant system. Okay, so now what I found that time is already over. So now I am going to end the today's lecture. So now it is time to conclude. First, it is time to conclude the lecture. So what we have seen, that at least for linear system, linear time invariant system basically, and I will extend that in next class for linear time varying system also, I can able to construct Lyapunov function using the theory of positive definiteness of matrices. And after that, Lyapunov equation comes into picture. Under what situation I have some kind of unique solution of, or I will get unique Lyapunov function. Unique Lyapunov function means I can able to create unique P. And what we found, that if A is Hurwitz, means if system is stable, and you can select Q, and Q in later part we have discussed that for simple choice of Q you can just take identity matrix. So if I select Q, then I can able to get unique P, and with help of that unique P I can construct the Lyapunov function X transpose Px, and I can tell that okay, this is the Lyapunov function for linear system. In this way basically we are working. Okay, in next class I will talk about how to talk about the exponential stability using the same Lyapunov function for the linear system or non-linear system, and after that I will extend this linear result for linear time varying system also. So if you have any confusion or question, then please let me know. Lecture is over from my side. Anyone? Okay, if you don't have any question, then I am going to end the today's lecture. Okay, so thank you very much.